again, what happens if I have same bases and I'm multiplying? What do? You add the exponents. Very good. What do I do if I have same bases and I'm dividing? You subtract. Very good. Now, whoops, x to the a minus b. Do you remember if I have a rational exponent, how to put that into radical form? The denominator becomes your index, and the numerator stays as a power of your base. So we will be using this property a lot today, okay? It's up there too. So the n, the denominator is always your index. The m stays your power. So for example, if I had 36 to the 1/2, this 2 becomes my index, and it's 36 to the 1 power. So here, I couldn't really simplify it, but converting it to a radical, I now have square root 36, which is 6. Right? Or 8 to the 2/3 would be cube root of 8 squared. What is the cube root of 8? 2. So really it's 2 squared, which is 4. Okay? So we have this property because in order to simplify, if I put the rational exponent into a radical form, I can then simplify it.
So when you keep writing something,
Simple. If I have 36 to the 1/2 power, right? I just walked you through this. Okay, so this is square root 36 because the 2 becomes the index, 1 becomes your power, so it's just 6. 27 to the 1/3. The 3 becomes your index, so cube root of 27 to the 1st power, which is just going to be 3. Cube root of 27 is 3. Very good. 49 to the 1/2. Should be able to do that in your head now. 7, because really it's square root of 49, which is 7. Good. Okay. So then when you get more than one term, there's two things you want to look for. You want to look for, do I have same bases or do I have same exponents? Okay? Because if I have the same exponents, that means I have the same index, right? This one is actually both. There's two ways I can solve this. I have the same exponent, so I can make them both into square root 10, right? So I can say square root of 10 times square root of 10, which is square root of 100, which is 10. Or I can notice that, oh, I have same bases. What do I do with the exponents? You add 1/2 plus 1/2 is 1, so I get 10 again. Okay, so either way, if you have same indexes and same bases, you can solve either way on that. Okay. 14 is the same way. If you look at 14, you should notice you have same bases and same exponents again. So you could do -3 and then add 1/3 plus 1/3 plus 1/3, which is just going to be -3 to the 1 power. Or you could change all of those into the cube root and have -3, -3, -3. There's 3 of something, you take 1 out. Okay. So again, either way, because you have same bases and same exponents. Okay. But 15, there's only one way to solve it. Do I have same bases or same indexes? Same indexes. See how that's both squared? These are both going to be square root. Square root 7, square root 21. Now that they're both square roots, I can combine them together and say square root of 7 times 21, whatever that is, but I wouldn't do that because I'm going to have to break it down anyways. So 7, 21, and 21 is 7 and 3. There's 2 7s. I can take 1 out. So 7 square root 3. Then it's simplified. Same with 18. If you look below it, 18 there. Again, see how I have 4 and 4? So I can make those both into 4th root of 3, fourth root of 27. Now that they're both fourth roots, I can make it into 1. 3 times 27. 27 I know is 3 threes. So then I end up with 4 threes. I can take one out. So my answer is just 3. Same with 17. 17, they're both cube roots there. So cube root of 3 times cube root of 9 would be cube root of 3 times 9. But break 9 down. Now I have 3 threes. I can take one out. If that denominator is the same, that means it's the same index. Again, right, half and half, 2 and 2. So I can change that square root of 2, square root of 32, which would be square root of 64, which is 8. And I can multiply. Practice putting rational exponents into radical form. And the reason we do that is because when it's something with a rational exponent, there's really not a lot I can do with it. But once I convert that rational exponent into a radical form, then I know how to simplify, because I spent the first half of this chapter learning how to simplify radicals. Okay? So we're going to use that property and convert it to a radical and then see what can I simplify. So let's start with something easy. X to the 1/6 would be what as a radical? 6th root of x to the 1, but you don't have to have the 1 there, right? How about 20? What would 20 be? 5th root x, very good. How about 21? Very good, okay. And here I need 7 of something to take one out. I only have 2 x's, so that's why I'm done. How about 22? Right, the 5 becomes 5th root, and the 2 becomes my power. And again, I don't have 5 of anything, so I'm done. So how else can you look at a rational exponent? They can be decimals or negative numbers. And like I've told you before, you never want to work with a negative exponent. You always want to fix it first. Okay, so how would I make negative 9/8 positive? How would I make negative 9/8 positive? You put it on the bottom. So it'd be 1 over 9/8, right? Because remember, you just switch levels to make it positive. Now I can write that as a radical, the 8th root of y to the 9th. Can I simplify the 8th root of y to the 9th? Yes, I have 9 y's. How many y's do I need to take one out? I only need 8. Right? So 9 y's. Here's 8. I can take one out. What's left? The 8th root of y. But what's wrong with this answer? You can't have radicals on the bottom, so how do I get rid of this 8th root y? Multiply by 8th root of y to the 7th power. Why 7? Because I have 1 y, I need 7 more to make a group of 1. So this would be, I'd have to do that to the top, remember? So 8th root of y to the 7th over y squared. How do I get y squared? I have this y times another y to take out. With the negative, so how would I make a negative positive? Flip it, put it on the bottom. So now that it's positive, now I can write it as a radical. So this would be 1 over 4th root of t cubed. Can I simplify that? I don't have 4 of anything, but what's wrong with that answer? You can't have a radical on the bottom, so I'm going to take the top and bottom times 4th root of t, because I have 3 t's, but I need 1 more to have my group of 4. So 4th root t over t. Decimals, look tricky, but not. Just put the decimal into a fraction. What would be 1.5 as a fraction? X to the 3 halves. 3 halves, right? If I didn't know that, I could say this is 15 tenths, and 15 tenths reduces to 3 halves. So I would say square root of x cubed, but then can I simplify that? Yes, because 3 x's, 2 I can take 1 out, and then I'm done. So if you have a negative, you have to make it positive and then fix it. If you have a decimal, you have to make it to a fraction and then simplify. Let's do one more decimal. What would 1.2 be as a fraction? 12 tenths, which is 6/5. Very good. So y to the 6/5, put that in radical form. Can I simplify that? Because I have 6 y's, I only need 5 to take 1 out. So it'd be y 5th root y. And I'm done. The other way, and the other way is actually easier because if you go radical to rational exponent, you can't simplify, you're just done. Okay, so it's a little bit easier going the other way. This would be negative 10 to what power? 1/2. Because there's really a 2 here, and that's a power of 1, but no solution. Why? Because you cannot have an even index and a negative radicand. What about 28? Or no, let's do 31. What would 31 be? A to the 2/3. Very good. 32 would be a to the what? 2/3. Okay, what I want you to recognize is that these are the same thing. This squared can be underneath the radical, or it can be outside the radical. Okay? And how does that come in handy? If you're doing something like 8 to the 2/3, and that'd be cube root of 8 squared, you can do cube root of 8 first, and then square it. So it'd be 2 squared, which is 4. Okay? That's how you would use that. So let's look, I want to look at some parentheses, right? Look at these 3 problems here. And what I want you to recognize is that they're all almost the same, but not quite, right? You see how this is all 7x with a 3, 7x with a 3, 7x with a 3? But the parentheses are all different, okay? So what I want you to recognize is these are not equal. This cubed is only going to the x. So if I was going to write it as a rational exponent, I would do this, 7x cubed to the 1/2. Okay? But this one, since it's in parentheses, I can write it as 7x to the 3/2. Because that is my m and 2 is my n. See the difference? If it's in parentheses, that makes a big deal. And again, when the 3's outside, it's the same thing. This would still be 7x to the 3/2. That 3 is still the m. It's still the power. Okay, so these two, again, are the same. The 3 can be underneath, or the 3 can be outside. How about 33? What would that be? C to the 2/4, which is 1/2. If you can ever simplify that, go ahead. And this one would be 5xy to the, oh, is there a 2 there? 1/3. 6 there. So this would be 5xy. So you were right. 2. 6/3, which is 2. Be confident. Come on, right? Looking, do I have same bases or do I have same indexes? And you should notice that you have same bases. Because what can I do? I can rewrite this as 6 to the 1/4, 6 to the 1/3. Now I have same bases. What would I do with the exponents? Add. Right? So 1/4 plus 1/3 would be 6 to the 7/12. Good. Which I can say 12, if you wanted to, 6 to the 7th, just to see if you can simplify it anymore, but we can't. If I look here, right, what do you notice? I have same indexes or same bases? Same bases. So I can rewrite this as y to the 3/9. 3/9. I can rewrite this as 9/3, right? But what is, simplify those, what is 3/9? What is 9/3? 3, good. Okay, now if I have same bases, what am I going to do with the exponents? Subtract. What is 1/3 minus 3? -8/3. Good.
I'm gonna hurt myself.
Right? Now we are where we were a couple of examples ago. How do I do negative exponents?
Oh.
You put it on the bottom, right? And then change it to a radical.
Why can't we leave it as that? Because yeah, why do you have to wrong with it?
I have
When we
8
get the
y's.
problems up here, it gives us
I
negative.
don't like myself.
I have 8 y's. How many group of 3 is that? So 2 y's. Y squared. Right? Multiply top and bottom times cube root of y, because if I have 2 y's, I need 1 more. So what would I get? Cube root of y over y cubed. Right?
I have a quote for you. So steady wins the race.
If you look at 41, what do you notice? Same indexes or same bases? Same bases. So this would be 5 to the 1/2, 5 to the 1/5. What is 1/2 plus 1/5? What? 7/10.
I knew that.
I don't get me.
So 5 to the
It's like the common
7/10
denominator.
would be 10th root of 5 to the 7th, which I can't simplify. It's done. One more. This is 1/7, right? This is 1/3. Add, what's 1/7 plus 1/3? 10 over 21. Good.
Wow.
Which would be the 21 of 7 to the 10th, which I can't simplify. I'm just done. Okay. But like I said, if you don't like that, you can use a calculator. It's fine.
What form are you trying to get it in?
All right, so 43, what do I see?
Same basis.
Same bases. 4 to the 1/6, 4 to the 1/3. I am dividing, so I'm going to subtract. What's 1/6 minus 1/3? Negative 1/6. Good. Make it positive. Change it into a radical. Right? I have 4 is 2 2's, right? But 6th root means I have to have a group of what? 6. So how many more 2's would I need? 6th root of 2 to the 4th power. Very good. So this would be the 6th root of 16 over 2. I'm done.
Excuse me, what?
Right? Because 2 to the 4th power is 16. And now I have 6 2's. I can take 1 out. Problem of the day. Who can figure it out? How am I going to do this? Do I have same base or same index?
No.
How am I going to solve that?
You could simplify the first one. Or both of them if you wanted.
Multiply.
Okay, so this would be to the 1/4, and this would be to the 1/2. Now what?
You just go ham.
How can I make those either same bases or same exponent?
Take the go. Yeah. So do like 2 18.
No. No. What's another way I can write 1/2?
2 4.
2/4.
Oh.
See that? Isn't that neat? Now I can say this is the 4th root
Wow.
of 18. The 4th root of 12 squared, right? Because that 2 stays as a power, which I can make 1. So 18 times 12 times 12, because I'm going to have to break it down here. So I'm not going to multiply. So then what? 18 is 9 and 2, 3 and 3, 4 and 3, 2 and 2, 4 and 3, 2 and 2. And I'm looking for groups of 4. 2. So 1, 2, 3, 4. 1, 2, 3, 4, and then that 2 doesn't have a partner. So 6, 4th root 2. How about this one? How do I make same bases or same index? 6 to the 1/2. 36 to the 1/3. So I can't make same index, right? 1/2 and 1/3, not going to happen. How would I make 6 and 36 into the same base? I can write 36 as 6 squared, right? So the top would be 6 to the 1/2, but now the bottom would become 6 to the 2/3, because 2 times 1/3 is 2/3. And now when I have same bases, what do? Subtract. What's 1/2 minus 2/3?
1.
Yeah.
That's 1/3.
So
No, 1 6.
3/6 minus
4 6.
4/6 is -1/6. Whoops.
Is a smart kid out of here.
So then I say 6 to the 1/6 with the 6th root of 6. I have 1/6. How many more would I need? 5 more. Whoops. So I'd have 6th root of 6 to the 5th over 6, and I'm done.